There we go. For a second, I was scared because we had a black screen, but now the screen is filled in. English or Spanish? Well, I only speak one of these languages. I have no expectations of this except that I'm gonna get my mind hurt. An innate quest within their essence. The deeper they explored the cosmic mysteries, the more enigmatic they seemed. Oh yeah, like physics is whack, dude. Like I don't know that I can explain like the inflationary period to somebody, or why it's called like reionization when it's actually the first ionization. These are things that you just shouldn't ask. Undeterred by this challenge, they persevered and produced. I'm an elizibar, by the way. Hi. With superluminal computers, humans are closer to unravel. Oh man, this is like there's an Asimov story. I think it's Asimov, where they make a computer to figure out like the key to everything, and the computer reinvents the universe. Yeah. Anyway. I have no idea what this game is either, except it involves puzzles and logic. Oh my god, I already know I hate this. Let's keep going. Welcome, engineer, to a transformative journey as we pioneer technology poised to revolutionize the world. This game's free on Steam, by the way. The developers like made it free like a week or two ago, and so I added it to my Steam account. And I was like, I gotta play this. Machine that operates in a strange language. Your task is to innovate and address these initial segments, constructing the original database with a vision of simplicity and elegance. Oh no. Oh no, I'm exactly the wrong person. Is there somewhere I can make the audio a little louder? Oh, there was a notification on the Steam page. Sorry, there's a notification on the Steam page where they were like, hey, this game has like some AI stuff in the intro sequence. So I guess all those like nebula pictures were AI or something. Okay. Oh boy. Oh boy. I should have just played Spelunky. Copy the content from the upper screen to the lower one. Some instructions are required, or provided. UBITS are mobile blocks with numerical value and color, which are long wires. Icons are static blocks that perform actions on UBITS. They're located on the toolbox below, though many are currently grayed out for now. Click next to proceed. I'm guessing this is next. The blue icons already placed on the board are port 0 and port 5. Okay, I see that on the here and here. Signal 0 is the input. Signal 5 is the output. Signals are... I like this kind of music. It's kind of chill. Like, it feels curious, but chill at the same time. Signals displayed on the right side of the screen. At the start, a UBIT spawns at port 0, taking its value from signal 0. Okay. When UBIT touches an icon, it activates the icon's function. If a UBIT reaches port 5, its value is transmitted to signal 5. Okay. So these blocks come in, and they've got whatever value from the left, and then they go out with whatever value from the right. That's easy enough. UBITS move along wires. Hold Alt to paint. Okay. Alright. Wait. Connect 0 and 5 with the wire, then drag the input icon from the bottom left corner. Oh, this thing. Okay. So I do this, right? What did I get wrong? Like that? I think we just did this right. What did I do wrong? Okay, we got that. Drag the input icon from the bottom left corner of the toolbox onto the wire. Oh! Okay, hold on. So we did this wrong? How do I delete? Alt right, okay. Alt right mouse, got it. Aha! So how do I know if I win? Do I just hit this and let it go? Okay, that's apparently it. Aha! We got it! First segment defeated. Okay, but we'll tackle operations, no problem. So we're basically making an adder? So something like this? I think we got it. All right, let's excuse me. Zoop the speed up. That's it. We have made an adder. Dude, I don't even know how those work in real life, okay? I'm just going to be honest with you, man. I don't know how digital adders work. I once had an engineer from Intel try to explain that to me. And I'm just like, but in your diagram, you're neglecting all the ground wires. He's like, yeah, they don't matter. And that just hurts me. It hurts me deep inside. A Caesar sounds kind of violent. Sorry, I'm just reading this text, trying to figure this out, man. If S0 is greater than S1, add them. If S1 is greater than S0, destroy it. Okay, I see the math we're supposed to do over here. 39 plus 2 is 41. 5 plus 74 is not here, so that one's destroyed. Then we take 66 and 3 and make 69. All right. Okay, so we need to bring these together. We're gonna do some naive stuff, okay? Now, naively, if we just wanted to add these, this is what we would do. But that's not what we want to do. We only want to do this if this guy is bigger than that guy. So how do I do a comparator? I don't feel like I got the logic pieces necessary for this. Oh! The junction does logic for me. So we actually should just nuke this thing. So I think this is what it wants me to do. Yeah, that's totally what it wanted me to do. Let's speed it up. Wait, why are we not getting any more inputs? What happened? What's wrong with hitting the recycler? What did I miss in the explanation? Remember, the UBIT resulting from merging other UBITs follows the direction of the previous UBIT with a greater value. If the values are equal, the new direction will be random. Oh, that's silly. That's so silly, but okay. So every terminal path has to have one of these things on it to keep requesting new signals. For a signal that is a cumulative sum of another one. For each target value in S5, output the cumulative sum of the values from S0. Okay, we're gonna need like some kind of memory widget or something here. Begin by setting the first value from S0 to S5. For each subsequent value in S0, add it to the last value previously sent, and then transmit the updated total. Input ports and duplicators. Alright. What was that? How does this guy work? Variations down, left, up versions. Duplicates the UBIT. The copy moves in the direction of the arrow. There is no wire in that direction, or if the direction of the arrow matches that original UBIT, it doubles its value without creating a copy. So we gotta make like a loop here, huh? Okay. No, that's wrong. I need to create a path. Let's see. So we need the signal. This one's stumping me a little bit. Like let's just say we put the duplicator here, right? How do we get to the variations of these? It just told us. The game literally just told us. Scroll over icons to label variations. So, like that. All right. So let's just play with this a little bit and see what happens. Fascinating. That is so not what I wanted, but that's fascinating. We just made a self-sustaining signal. I'm gonna need a little hint. It hit me. Oh, I see. I see what it wants. All right. We'll do this, and then we'll figure out how this works. Whoa, what happened, game? And then we put the input requester there. So we're doing the math here with the adder. Then we're storing the last signal here and sending it back around. This triggers a new poop. Okay. I see how this works. Gosh, I felt like I was close, but I was barking up the wrong tree because I was trying to loop the signal just back on itself. And here, let me pause for a second. Because what I was thinking, and I see why it's stupid now, is to take like this guy and pipe the signal back onto itself so it's always duplicating over and over again. But that's not going to get the fresh information out. Alright, I understand exactly why this works, and I feel kind of dumb for not thinking about it, or thinking of it sooner. Yeah, sorry I used the, oh, there's Chivos for this. Hold on. Hold on. How many Chivos are... Oh my gosh, there's 20 achievements for this thing. What a nightmare. Each solution you find is like a spark, igniting the circuits of this nascent system. We're only at the beginning, but already I can feel the potential growing. Your efforts are invaluable. Oh, no, some of the icons are not recommended, indicating it's too early to use them. While you're free to do so, I would advise against it, but honestly, who's going to stop you? Nobody! Let's aggregate with the aggregator. So, we did this. Oh, we don't have more icons yet. Oh, we can just drag them out. So just because they're ghosted doesn't mean we can't actually use them. They're just not recommended for this situation, I guess. So like I could drop this guy in here, right? And this won't actually change anything. It's still going to do the same thing, but if I come in here and I'm just like, oh yeah, what if, what if I'm a dodo and I do this and I just wreck everything? It's like Pac-Man, he's eating everybody up. Oh, how wild. Okay, there's some crazy stuff you can do with this. Can we get back out to the menu? Here we go, exit. Alright, we're already getting to stuff where this is like a little harder than I want it to be, but we'll do another couple of these. Program has two raw signals to generate a modulated one based on a predetermined formula. Oh gosh, we gotta do math. Add 5, subtract 5, and then duplicate it. Okay. How do I edit the value? Oh, like that. What? And that's 5. Add 5 to S0, subtract 5 from S1, and double it. Sum those and output the result to S5. Okay. Four, 17, 22. We got it! Look at that! I am the genius. Okay, this program creates a custom pixel pattern. Color UBITS by port 0 to follow the pixel pattern, neutral, red, magenta. Then set the values to the pixel value using the definer. Oh, Lord. Huh. So we need these to come in neutral, red, magenta. So it seems like we got to split the wire in 3 ways or something here. Or generate 3 signals from one input. The screen pointers will shift 1 position to the right. Oh, does that mean this? Is this the pointer? Alright, so if I come in here and I just draw a wire and I hit the button, so it'll send out a 0 neutral. Okay. So our inputs are 0 neutral wire, or neutral valued things. I feel like there's a couple ways to do this, and we're gonna just do something dumb. Because we got a colorizer here. So what if I do something like this? How does this work? Oh, I see. So we do that. Okay, we have to make purple. So we're actually gonna need 4. All right, let's scrap this. We're gonna need 2 red outputs. Alright, so let's do this, where we can send a signal straight through. I'm probably doing this way more complicated than it needs to be. Oh, we should just do this. Let's put our input requester, like, right here, maybe? Alright, so we come in here, we set this to 170, which is what they have to have. Then we come through, and I need a duplicator. So the neutral signal can go right through. Then I need a red. Nope. Can I move these? Oh, I can. Hold on, that changes how I'm gonna lay this out. There you go, buddy. Yeah, first thing we're gonna do, we're gonna set that to 170. Then we're gonna come down here. I need a neutral signal to go through, which means I need a duplicator right there. Then we're going to have a wire that comes out this way. We need another duplicator. Make the red. We're going to need these guys. To make magenta. Oh, let's get rid of this. And we'll just use like that. We'll define the signal at the end. This is terrible, and we'll have to like adjust a lot of this, but in principle, something like this is what we need. Alright, let me just send a pulse through. Okay, we need a conveyor. Let's see if we get the timing right to make this merge happen. Okay. That worked. So let's put a... something like this. Let's see what happens. So neutral. Oh, we lost the neutral. Hold on. My bad, ski. Not quite the desired result. So the timing is what's going to get us right here now. Let's do one pulse again. Okay. So we actually need... I am so doing this wrong. If you're doing it wrong and it works, I guess it's not wrong, huh? Look at that! We somehow made the dang circuit they wanted. In probably the most horrifying, appalling fashion, but we did it. Alright, let's try color test 2. How many of these puzzles... Is this it? Is this the whole field of puzzles? Oh no. Oh no. Oh lordy. Well, we'll give this stage a shot, and then I think I might this might be where we've met our match. Look at this output gibberish over there. You want me to deal with ASCII characters now? Wow, indeed. Read SO and send to S5. Only... Oh, so we're stripping the color. Oh, it's a discriminator! Okay. Discriminate red characters from right ones, you need a sensor. Connect the sensor to a triggerable icon with a red wire. Scroll mid-mouse on paint mode to select this wire type. Oh yeah, we're definitely gonna have to do some experimenting here. So let's draw a little wire. How did it say to draw a red wire? I don't know what I'm doing, so you're just gonna have to bear with me as we experimentalate. Okay. Okay. Does that need to be like this? I don't understand. Aren't we doing what it said? Connect the sensor to the thing with a red wire. Say A and B, which can be active or inactive. If state A is active, B is inactive. If triggerable icons with a red wire enter state B. If not met, they revert to state A. For example, a triggerable conveyor whose state A is active is connected to a red color sensor. If the UBIT is red, the conveyor will enter state B and will be ignored by UBITS. Okay. I don't understand the flipping, but that's what we had to do. Sorta. We're getting the signal slightly wrong. Oh! Hold on. Something like this. Maybe. So, we want... It's gonna work? Yeah, there we go. So we need to make sure the gate is set when the other block gets to it. And so that means we have to time it so that the thing going down to hit the sensor is hitting at the same time as the thing that's actually going through. Okay. Well, we got that one. That looks scarier than it was. Or did we not actually beat this one? I guess we didn't beat this one or something. Did we not get it? I don't know what that means. Alright, I'm not really sure why we can't get to these other things. But you know what? That's alright. We beat... Well, I don't know that we can really say that we beat this one, but we came pretty close to it. This is a neat little puzzle game, but man, it hurts my head. We're gonna change games now. If you're watching this on YouTube later, thank you so much for checking this out. You should go check this game out if you like puzzle games. It's free on Steam. Excuse me. What a time to have a hiccup. Time of game. It's the type of game conceived for elizibars? No. No, it is not. This is the type of game conceived for people who enjoy programming as a hobby. Because that's essentially what we were doing. Is we were laying down logic segments. This is just code flow. It's just represented graphically instead of in, assembly commands. In fact, that's probably really what we were doing. Is basically we're just screwing around with assembly language, which I don't do that for fun. I don't do that at all if I can avoid it. ABIDOS documentation, power-ups, like slot for start, consult guide, validate solution, repeat for every segment, retrieve disk, deliver to the central database. This is a neat little game. I'm going to tab out for a second. So I can pull up the store page. And just kind of show you, their store page shows, some of the really crazy stuff later on. We were definitely in amateur hour. Look at these code flows, man. Check some of the stuff out up here. Just look at this. Look at this. This is But that was kind of fun. I don't know why we couldn't keep going. Why we didn't get more, but that's all right, man. We don't need more. You should go check this out though.